Okay, so number 93 says we're graphing two full periods. Y equals 5 halves cosecant of x minus pi. Okay, so in general, I've got a cosecant wave. I need to graph two periods of it. The period is 2 pi divided by b, and b is an understood 1, so the period is just 2 pi. And the phase shift is negative c over b, so plus pi over 1, which is pi. So we're going to go to the right pi. Alright? So normally I would graph a cosecant of reciprocal sine. Doesn't really matter though right now. So period 2 pi. So 1, 2, 3, 4, 5, 6, 7, 8. I'll let this be 2 pi. And this be 4 pi. And 1, 2, 3. My amplitude is 5 halves, so I'm going to go up 2.5 and down. Well, vertical stretch in this case, but amplitude the same, right? It is not a horizontal. Okay, and then down 2.5. Okay. Okay. I'm going to draw a normal sine wave. If you want to go ahead and move it pi, you can. So, well, actually, I might as well go ahead and do that. Okay, so normally sine would start here, go up, come down, go down, and then right here, right? But I'm going to move to the right pi, and pi is exactly half of the circle, or the period, right? So if normally I start here, then I need to move to the right pi, I'm going to start here. So I'm going to think of it as starting my sine wave here. I go up, come back down, minimum, midline, max, midline. And then I'm going to continue the wave this direction. So I'm going to go down and up. Okay? So we actually end up with a negative sine wave. Is basically what we're doing. Okay? Yeah. And then we're drawing cosecant. So cosecant is a reciprocal of sine, meaning every time sine is 0, cosecant is undefined. So we should have a vertical asymptote every pi. And every time sine has a minimum, cosecant should have a max. And every time sine has a max, cosecant should have a and there you go. Okay. So just this little sine. This is 2 pi. This is pi. And this point right here. Just to that point right there. There you go. Thanks. Did you get my message? They'll explain it. Yeah. Okay. All right. Number 95. So 95 is cosine inverse of 0. Sorry. Cosine inverse of 1. And so then the idea is cosine inverse of 1 equals what? Well, it equals some angle. And so if you take cosine of both sides, cosine is an operation, so you can't put it behind it. So then you get 1 is cosine of what angle? And if you look, cosine inverse only exists from 0 to pi, and cosine is 1 at 0. So my answer is 0. Okay, 97. We've got sine inverse of the negative square root of 3 over 2. So sine inverse of negative square root of 3 over 2. So the question is, sine of what angle is negative square root of 3 over 2? And remember that sine exists only from negative pi over 2 to pi over 2. So sine inverse of negative square root of 3 over 2 is a negative pi over 3. So 60 degrees this way is pi over 3. Negative 60 degrees is negative pi over 3. So the answer is negative pi over 3. 99. Tan inverse of the negative square root of 3 over 3. So tan inverse also only exists from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2. So when I think about tangent being this, tangent of what angle, right? I look at these angles and I think, okay, tangent's never going to be negative up here, so it's got to be down here. Tangent is y over x. So we take 0 over, or sine over cosine. 0 over 1 is 0. This right here is negative 1 divided by the square root of 3. So if you think about that, negative 1 divided by the square root of 3. If you rationalize top and bottom, multiply by square root of 3, then you're left with negative square root of 3 over 3. So tan inverse of negative square root of 3 over 3 is negative pi over 6. Okay, 101. Sine of cosine inverse of 0. Okay, so cosine inverse of 0 is some angle, right? So that, and where it's true that cosine of that angle is 0. Yeah, so if you take the cosine of both sides of cosine inverse of theta, cosine inverse of 0 equals theta, then you get cosine of theta equals 0. So, cosine inverse of 0 equals theta, take the cosine of both sides, okay? So leaves you with 0 equals cosine theta. So cosine is 0 at what angle? At, and remember cosine only exists from 0 to pi, at pi over 2. So this right here, this theta, is just pi over 2. So I'm actually asking you to find sine of pi over 2, and sine of pi over 2 is the y value, which is 1. Okay. 103. Tangent of cosine inverse of negative square root of 3 over 2. Okay. So again, this is an angle. So it's asking cosine inverse of negative square root of 3 over 2 is an angle. And what you ask yourself is cosine of what angle is that? So cosine exists from here to there. Cosine's only negative in the second quadrant for what we exist for. So cosine is negative square root of 3 over 2 at 5 pi over 6. So I'm actually asking you to find tangent of 5 pi over 6. So tangent of 5 pi over 6. So 5 pi over 6 tangent is sine of a cosine, which is just y over x. 1 divided by the negative square root of 3 is negative square root of 3 over 3. Okay. So these are different answers, 99 and 103, even though this is tangent, inverse of negative square root of 3 over 3, and that's at negative pi over 6 because tangent inverse only exists over here, whereas this one is just what's tangent of 5 pi over 6, and tangent exists everywhere, so, well, except for cosine, but, so tangent of that is negative square root of 3 over 3. Okay, 105. So 105 says cosine of tan inverse of 3/4. So tan inverse of 3/4 is some angle, right? So if tan inverse of 3/4 equals theta, then what that's telling me is that 3/4 is tangent of that angle, right? So tangent is positive. Tan inverse only exists in the first and fourth quadrant, and tan inverse is positive in the first quadrant. So draw a triangle in the first quadrant and let tangent be opposite over adjacent 3/4, which means that the hypotenuse would have to be 5. 3, 4, 5. And then the question is, what is cosine of that angle, right? Cosine of theta. So cosine of theta would be adjacent and hypotenuse. 4 over 5. There you go. Okay, 107. Tangent of sine inverse of negative 3 over 5. Okay. This is some angle. right? So sine inverse only exists in the first and the fourth quadrant, and sine is only negative in the fourth quadrant. So I'm going to draw a triangle in the fourth quadrant. Let that be theta, and sine is opposite over hypotenuse, so negative 3 over 5. And if that's 3 and 5, then this has to be 4, 3, 4, 5. So then the question is, what is tangent of that angle? And tangent of that angle is opposite over adjacent, negative 3/4. And there we go. So 109. Sine of tan inverse of negative 1/3. Okay, so tan inverse of negative 1/3 is an angle. So if tan inverse of negative 1/3 is an angle, and that means negative 1/3 is tangent of that angle, right? Tangent is only, tan inverse only exists in the first and the fourth, and it's only negative in the fourth. So, draw a triangle in the fourth quadrant. Let that be theta. Tangent is opposite over adjacent, 1 over 3, and the negative 1, or the negative goes with the 1 because that's the down direction as opposed to the right direction for the 3. And then I need to find the hypotenuse. This is not a Pythagorean triple, so I need to do Pythagorean theorem. A squared plus b squared. So 9 plus negative 1 squared is 1. So that is the square root of 10. Okay? So then the question is, what is sine of that angle? Sine is opposite over hypotenuse. So that would be negative 1 over the square root of 10, or negative root 10 over 10. Okay. 111. Sine inverse of sine of 2 pi over 3. Okay. 2 pi over 3, if you look at your unit circle, is right here, which is out of the bounds for where sine inverse exists. So if it had been something like pi over 3, then I could have just canceled these out. The answer is pi over 3. As it is, I'm going to have to go ahead and evaluate the expression. So sine of 2 pi over 3, sine of 2 pi over 3 is square root of 3 over 2. So when I ask you then, what is sine inverse of square root of 3 over 2, you have to recognize that sine inverse only exists from negative pi over 2 to pi over 2. So sine is square root of 3 over 2 at pi over 3. So the answer would have to be pi over 3. Okay. 113. So 113 is cosine of tan inverse of x over 2. So tan inverse of x over 2 is some angle, right? What I need to know is I've got, well, tangent is positive x over 2. Because nothing indicates that it would be negative, and tan inverse only exists in the first and the fourth, so we're in the first quadrant, right? So tangent inverse of x over 2 means tangent of, let's start with this. Theta equals x over 2 equals tangent of theta, right? So tangent is opposite over adjacent, so x over 2. And that means the hypotenuse is a squared plus b squared equals c squared, hypotenuse equals c, right? So this is the square root of x squared plus 4. And then the question is, what is cosine? So cosine of theta is adjacent over hypotenuse, 2 over the square root of x squared plus 4. You could rationalize, but I don't need you to. And there we go. Okay. 119. From a point on a level ground 80 feet from the base of a building, the angle of elevation is 25.6. Approximate the height. Okay. So you got a building, and the angle of elevation 80 feet from the building is 25.6. What is the height of the building? Yeah? So height and 80 are opposite and adjacent, so I've got tangent of 25.6 degrees equals h over 80. And if I want to find h, I just multiply by 80. Make sure you're in degree mode. So then I do 80 times tangent of 25.6. 80 times tangent of 25.6. And we get 38.33 degrees. Yeah. Oh, degrees. That was ridiculous. 38.33 feet. Yeah, always make sure you know what unit you're trying to find, or what you're trying to find, the height. It's not going to be measured in degrees. Okay, 120. Two buildings with flat roofs are 60 yards apart. The height is of the shorter building is 40. Okay. From its roof, the angle of elevation. Okay. Interesting. Okay. So I've got two buildings. The buildings are so weirdly shaped, but they are. Okay. These are 60 yards apart. And the height of the shorter building is 40. The angle of elevation from the edge of the roof of the taller building, from its roof, the shorter one. The angle of elevation to the top is 40 degrees. Okay. Find the height of the taller building. So then the question is, what is that? Okay, well, if I know this is 60 right here, and I got this angle, then I can find this length, right? And if I know that length, and then I know this is 40, then I can just add it. So x plus 40. Alright, so tangent of 40 equals x over 60, which means x equals 60 times tangent of 40. 60 times tangent of 40. 50.346. 50.346 yards. So this right here is 50.346, which means the entire height of the building is 90.346 yards. Okay. 121. Okay, so 121 says you want to measure the height of an antenna on the top of a 125-foot building. From a point on the top of the building, you measure. Okay. I don't know why I made this building so thin, but I did. Okay, so it's got some antenna. Okay. So, 125-foot building. From a point on the top of the building, you measure the angle of elevation from a point in front of the building. Okay. So, let's go with this angle. That's fine. 68 degrees. And then to the top of the antenna, the entire angle is 71 degrees. How tall is the antenna? Okay. 10 years can't do with it. And then like 3 decimal seconds. Oh my computer. I've got opposite. I don't know hypotenuse. I don't want to do hypotenuse because they're different for each triangle, but I do know that the adjacent is the same. So I'm gonna let this be y, and the goal is to solve for x, right? I don't need y. I'm just using it as a means to the end. Okay. So what I know is that tangent of the smaller angle, 68 degrees, equals just 125 over y. Okay. I also know that tangent of 71 degrees equals opposite, which is x plus 125, over adjacent, which is y, right? So if I want to solve for x, what I could do is just solve both of these equations for y and set them equal to each other, yeah? Or solve for y and substitute in there. It just might be easier just to do what I'm about to do. So if I solve for y, I'm going to multiply both sides by y, and if you do that, you end up with, sorry. So I multiply both sides by y, and then I divide by tangent of 68, and you end up with y equals 125 divided by tangent of 68 degrees, right? So in actuality, I could just figure out what that is right now and plug it in for y, because that is just a number, true. I mean, why not? So 125 times tangent of 68, which is 50.503. Yeah. So if I let that be 50.503, then to solve for x, all I'm going to do is multiply by this and subtract that. So 50.503 times tangent of 71. And then subtract 125. And what did x? So, in solving this equation, I multiply by 50. Actually, just kidding. I always tell you guys that if you want your answer to be correct to the 3 decimal places, then you need to go a little bit longer when you're going to use that number. So 50.503278. Okay. So I'm going to multiply that times tangent of 71. 50.503278. I could have just grabbed that, but I'm going to go ahead and use what I have written down times tangent of 71 minus 125. And you get 21.672. And it's set to the nearest 10, so that'd be 21.7, but I'm going to go ahead and go with that, and that is in feet. Okay, really tall antenna. Okay. 122. So 122 is use the figure shown to find the bearing. Okay, so it gives you that this right here is 55 degrees. And they want you to find the bearing from O to A, the origin to A, right? So in fact, you are traveling north, and then you are traveling, if you go this direction, you're going east, yeah? And 55 degrees this way means 35 degrees this way, because I gotta add it to 90. So your answer is north, 35 degrees east. There you go. 123. So you end that's boring. Didn't chase it anymore. Okay, so from O to A is down here, and this is 55 degrees. So I guess the biggest thing is just knowing that you always use the y-axis in this case to determine your bearing. So you are going south, and then you're going 35 degrees west, right? So your answer is south, 35 degrees west. 124. A ship is due west of a lighthouse. Okay, so we'll let this be. Well, just okay. So we got your lighthouse, right? And it's beaming light. Okay, so a ship is. This scale is wrong because this is going to be miles. 12 miles due west. You got your ship. And then your second ship is. Oh, no, it doesn't even say. It just says it's due west. The second ship is 12 miles south. Interesting. So this is 12 miles. The bearing from the second ship to the lighthouse. Bearing from the second ship to the lighthouse is north, so up north, and then 64 degrees east. So this right here is 64 degrees east. And then the question is, how long is that? Okay. So, I know that this is opposite, this is adjacent, so tangent of 64 equals x over 12 multiplied by 12. And you got your distance. Anticlimactic question. Okay. Tangent, or 12 times tangent of 64 degrees is 24.604. X equals 24.604 miles. Okay. 125. From city A to city B, a plane flies 850 miles at a bearing of north 58 degrees east. 58 degrees east. Okay, so from city A, we're gonna go north, and then here is 9 degrees, so 45, so 58 is somewhere in here. Okay, so it's 158 degrees for 850 miles. From city B to city C, the plane flies 968 degrees at a bearing of south and then east. So I'm going to go south and then 32 degrees east. So 32 degrees east for how long? 960. So that C, south and then 32 degrees east. So 960 miles. At a bearing of south 30. Okay. Find the nearest to the nearest tenth of the mile the distance from city A to city C. So I need to find this distance. Right. And the only way that I'm able to do that right now is because if this is 58 and so is that. You got parallel lines. Oh, wow. Okay. You got parallel lines cut by a transversal, so these are alternate interior angles. This is 58. 58 plus 32 is in fact 90. So that should be a right angle. That is kind of a right angle. The way that I drew it? Okay. Okay. So if it's a right angle, then I can use Pythagorean theorem. 850 squared plus 960 squared. Take the square root of that, and you got your hypotenuse. Squared plus 960 squared is 1,282.224629. To 3 decimals, I would say 1,282.225. part A. And then for part B, what is the bearing? From city A to city C. So, okay, the bearing is going to be, well, it kind of depends. It's either this right here or it's this right here. And so the only way that I know that is if it's past 90 degrees on this, then then I switch to south instead of north, because you don't go north and then 100 and something or over 90 degrees east, okay? Because now you're going south. And so I'm almost done. So I need to find this theta. So I've got opposite and I've got adjacent. So I know that tangent of theta equals 960 over 850. So theta equals tan inverse of that. Might as well just knock off the two. Sorry, it's not even on the video. So tan inverse of 96 divided by 85, and you get 48.47786 degrees, or 87. So if this is 44 or 48, sorry, 48.477 478, might as well, because we're not going to do anything with it. Okay, then this is over 90, right? So I'm going to go ahead and say 180 minus 58 minus 58.478, I think it is. And this right here is 73.522 degrees, which means my final answer is south 73.522 degrees. What was your question, Rankford?
This before I turn
Which one? Oh, I don't know how it works it out.
Oh. Alright.
Okay. So, 126, it says d equals 20 cosine of pi over 4t. The maximum displacement is just the amplitude, so that's 20. I'm going to find c first. The time required for one cycle is the period. Period is 2 pi divided by pi over 4, so times 4 over pi. I cancel out and look at 8, so that is 8. Oh, okay, it's measured in seconds, so 8 seconds. I guess this would be 20 centimeters then. And then the frequency is 1 divided by the period, so it is 1/8 of a wave per second. Okay, so 127. D equals 1/2 sine of 4t. The amplitude is, or the maximum displacement is 1/2 centimeter. C, 2 pi divided by 4 is pi over 2. So that would be pi over 2 seconds. And then 1 divided by that would be 2 over pi waves per second. If you want to put that decimal, that might make a little bit more sense. But anyway, that's the end of that.